This is Physics Oscillations by Says Park. The purpose of this lab is to track the motion of a spring mass system that has a mass oscillating in an arc. Also to use a computation model to determine if the model follows the energy principle and compare the computational with the experimental. A preview of the results. Since the systems, which is mass, spring, and earth, total energy remains constant at 0, it demonstrates the energy principle. My period of oscillations for X was 1.682 seconds, and for Y was 1.51 seconds. The fundamental principles in this lab were Newton's second law, which is a net interaction between systems and surroundings, which is the net force, to the observed motion change in momentum. From this law, we can get the position update formula and the velocity update formula. And the second principle is the energy principle, which states that the change in a system's energy equals the sum of the work done by its surroundings and the thermal energy exchange between them. So this is Newton's second law. These are the formulas derived from it. These also are some formulas that are derived from Newton's second law, and energy principles right here. Assuming that there are no external forces acting on it, meaning like there's no surroundings, only system, no surroundings. The procedure was to use tracker and track the position from the oscillating mass every frame. Then the X and Y positions from tracker were then transferred to a CSV file. Then using a code on GlowScript, I created a computational model of the spring mass system. And then I uploaded the CSV file into GlowScript to create the simulation. Here's a video of a spring mass system oscillating, and then using tracker I found these graphs. Using GlowScript we made a computational model, and then we had initial conditions, which the ball's mass was 0.402, and the position of the ball was at this position, and the velocity was 0. Gravity, of course, is 9.8. Then the spring constant, relaxed length. Some more code. Here we can see F net is equal to F grav plus F spring. F spring is right here, F grav is right here. These are the velocity and position update formulas. And kinetic formula right here. Then UG, US. After putting the CSV file into the GlowScript, we get this right here, which is a simulation of the spring mass system. And then these two graphs, one at the Y position and one at X position. Some sources of error in this lab were that there were no external forces. We assumed that there were no external forces, so there was no surroundings, but in real life there is work done by the surroundings. And then in tracking, we used our fingers to place a center of mass in the tracker, so that could definitely lead to inaccuracies. Was the energy principle satisfied? Well, we said that the change in energy should be 0, and if you look at the graph, it is. You see the orange line right here is the delta E, which is the change in energy, so that is 0. When comparing X and Y oscillation periods, we can see that they look very similar, but there is slight deviation. This could be due to having the tracker data be inaccurate because we use our fingers to put the center of mass, or the spring mass system having more motion in the X axis than the Y.